In this next step, we're going to talk about something called standard form. And standard form for a linear function looks like this. We've got ax plus by equals c. So it's different than the y equals mx plus b form that we wrote up here. Okay, so this is something that we'll call slope-intercept form. We'll talk about that in a couple sections. This is called standard form, and this is what we're going to be working with for the rest of the notes. So really all we're going to be doing here is I'm going to be teaching you how to put something into standard form. So there are a couple rules that you have to meet. So first rule, A, B, and C all have to be integers. Okay, and remember, integers are whole numbers and their opposites. Okay, so 1, 2, 3, 4, 5, but also negative 1, 2, 3, 4, 5, and 0. So they all have to be integers. No decimals, no fractions, nothing like that. With a greatest common factor of 1. That part is important too. So say like A, B, and C are all multiples of 2. That means it's not reduced down far enough. Think of it like a fraction. Like if a fraction you had 2 over 4, that wouldn't be reduced. So this standard form equation is the same. You have to have it reduced down. So if A, B, and C have any common factors, you need to reduce it in order for it to truly be in standard form. All right, and then A has to be positive. All right, so really B and C could be negative, but A has to be a positive integer. All right, so those are your rules for standard form. For example 3, let's get our equations into standard form. So start first of all by actually getting it into this form because it's not in that form right now, and then we'll worry about these rules. Okay, so first thing we're going to want to do is this x needs to be on the other side here. So we're going to subtract the 3x from both sides. Okay, so we will have a negative 3x, positive y equals negative 9. So the form looks good. I have a number in front of my x, then I have my y term, and then on the other side of the equals I have my constant, which is c. Okay, a, b, and c are all integers with a GCF of 1. So negative 3, 1, and negative 9. All three of them, there's nothing that they have in common, so that rule's good. But a has to be greater than or equal to 0. That's being broken right now because it's negative. So what you can do is you can divide the entire equation by negative 1. So divide this term and this term and this term by negative 1. So divide here, and we're left with a positive 3x. And then divide positive y by negative 1, we're left with a negative y. Equals, and then on the other side, divide a negative 9 by a negative 1, we're left with positive 9. So this is my equation in standard form. So now, the reason that we have all these rules is because technically, like, you could multiply or divide this by anything you want, and you'd have an equivalent equation. We don't want an equivalent equation. We want there to only be one possibility. All right, so this is the one and only possibility. Identify A, B, and C. I do not want you to just write A, B, and C under here. I want you to actually write out A equals. A is whatever's attached to the x, and that's a 3. B equals whatever's attached to the y. That's technically a negative 1. We don't ever write the 1, but that's what's there. And then the constant is the number floating by itself on the sides. That's the 9. Make sure you actually write out A equals, B equals, and C equals. Okay, this one. Start with the form. Remember, A, x plus b, y equals c. So here the constant is in the wrong place. So let's start by just getting it into the right form by moving the 9 over to the other side. So now we have 3x minus 6y equals 9. Okay, so a, b, and c are all integers. That's true, but they don't have a GCF of 1. 3 and 6 and 9 are all multiples of 3. So just like we divided by negative 1 here, we're going to divide the whole equation by 3. Okay, so 3x divided by 3 leaves me with just an x. Negative 6y divided by 3 leaves me with negative 2y. Equals, and then 9 divided by 3 is 3. And then a has to be positive, and it is. There's a positive 1 in front of the x. So that is your official standard form. So hopefully you see what I mean about only having one possible answer, because this is still an equation. You would get the exact same line if you plotted this versus plotting this, but we want to make sure that everyone's coming up with the same answer, because everyone would come up with this answer as long as you follow the rules. So a equals 1, because there's technically a 1 in front of this x. B equals negative 2, that's what's attached to the y. Don't forget about the negative. And then the number by itself on the right-hand side is 3. Okay, last example here. We're going to find X-intercepts and Y-intercepts. So if you guys remember doing this from Algebra 1, the way you find Y-intercepts, or I guess let's start with X-intercepts, is you set Y equal to 0. So the X-intercepts is where your graph crosses the x-axis, and whenever you're on this line, the y value is 0, because you haven't gone up, you haven't gone down, your y value is set at 0. So to find where you cross this line, you plug in y equals 0, and then you do the opposite for the y-intercepts. For y-intercepts, you set x equal to 0, because if you want to know where we're going to hit this line right here, you know that the x value is 0. You haven't gone left, haven't gone right, all of these x values are 0. So that's what we're going to do with this line right here. So find the x-intercepts by setting y equal to 0. So negative 2x plus, and then instead of y, I'm going to use a 0, minus 4 equals 0. So now you can see I only have one variable. And when I only have one variable, I'm going to be able to solve for it. So I have negative 2x minus 4 equals 0. So I'm just trying to get that x by itself. So I'm going to add 4 to both sides. Just the negative 2x is left, and then there's a 4 on the right-hand side, and I'll divide both sides by negative 2 to get the x by itself. So I end up with x equals, this reduces down to a negative 2. So I'm going to plot that. My x-intercept is a negative 2, so I go 1, 2 units to the left, and then plot a point there. Okay, so now I can do the same thing for my y-intercepts. For my y-intercepts, I set x equal to 0. So I have negative 2 times 0 plus y minus 4 equals 0. So this is just 0, so I'll rewrite it without it. So y minus 4 equals 0. So this one's actually a little bit easier. All I have to do here is add 4 to both sides to get the y by itself. So these will cancel, and I end up with y equals 4, positive 4. So I go up 1, 2, 3, 4 units, plot a point right there, and then all you have to do to draw a line is have 2 points, and then you just draw a line that connects those points. So once I've got my y-intercept and my x-intercepts, I've got all I need to plot that line. All right, so that is it.